Hello everyone, my name is Muhammad Tayyab Ali and today I am going to present my paper titled Simulation of Container Terminal for Generating a Test Dataset by Data Fidelity. In Container Terminal we have so many parameters, for example number of QA cranes, number of yard cranes and the number of yard trucks and different scheduling policies. The technical issue is to find the optimal solution under different circumstances or equipment parameters. For finding the optimal solution, we propose our model based on four different steps. The first step is the resource allocation, in which we will define the number of QA cranes, number of yard cranes, and the number of yard trucks. The second step is the configuring the container terminal, which is based on configuring area. For example, the yard blocks and the YT garage, the berth, and the allocation of routes for the yard truck movement. And then we have the scheduling process, which will define the equipment working in the container terminal. And the fourth step is the generating logs, which will help us to simulate the overall working of container terminal. We allocate one QA crane, one yard crane, and 20 yard trucks for the resource allocation. And then we have berth. We define the berth allocation, gate allocation, and the yard blocks allocation in configuring the container terminal. And then we have the scheduling process, in which we define the processing time of QA crane and movement time of the yard trucks, and we will also define the processing time of the yard cranes. And then we have the fourth step, which will generate the logs. So our logs based on two objects. Firstly, we will focus on active objects, which will work on the time, location, equipment, and the container. Our model is divided into four sub models. The first sub model is used for the allocation of vessel and holding vessel in queue. The second sub model is used for the yard truck arrival at the quick run position and unloading containers from the vessel. The third sub model is handling the number of arrivals of the yard trucks and the road trucks at yard block side. And for handling the road trucks and the yard trucks, we define the priority, which will help the yard crane to handle the bottleneck of the container terminal. The fourth submodel is for the road truck arrival with the different timestamp, which will take the container from the yard block and then leave the container terminal. Here I will try to explain that why the data level fidelity is necessary rather than the queuing level fidelity, and what is the advantage of data level fidelity over queuing level fidelity. So as we can see in figure 5, the report generated by the Arena, it doesn't show us the data gap between the arrivals of different yard trucks and the road trucks. So as we can see that it doesn't allow the operators to study the detailed information, and it didn't show the history of operations in container terminal. So to handle the performance, we generate the data logs. For that we use the microscopic approach, which record the information of each equipment. As we can see in this slide, we have three different columns of our data set. The first column is the equipment ID and the transport ID. The second column is based on the activity performed by the equipment and the transport. And the third column is showing at what time each activity is performed. So the purpose of generating logs is we are able to see the data gap, the time gap between activities performed, which we cannot get by using the queuing level fidelity. And we are able to see the in-depth information in the container terminal. So based on results, we have different conclusions. For example, we can only perform optimization if we will know the time gap between entities, which can only be found using data level fidelity. And data level fidelity could be useful in decision making process to increase the container terminal productivity, because optimizing the terminal using data level approach is more useful rather than hit and trial method using the queuing level fidelity. And the simulation becomes very easy by using data level approach, supporting data level fidelity. Thank you very much for giving your attention to me.